such a way that the processing can be done. So it can be either device on device itself. We will be talking in the next slides what type of devices we can use. And second thing is nearby edge servers. So that is also possible with that. By this way, what will happen is we will be able to implement the AI on the and process the data with locally, as well as, when you talk about local servers and all, it will be very much real time and nearly what we can say instantly we will be able to get the decisions. So this will be very beneficial when it talks about, like, for example, smart security camera is there. We kept a camera and we have edge AI over there. And it is evening time. Certain college is there. And we kept a camera over there. We want to identify anyone intrusion is taken place or not. For that purpose, we need not collect the data and send it to the cloud. Instead of that, if we install our AI, that is edge AI, it will be able to detect there itself on the camera itself. So once the camera detects the person, it will generate the alarm and all, such that processing will be very much faster and instant decisions will be taken place. Along with that, I already told that response time will be very less. And second thing is it reduces the bandwidth usage also. And not only that, the information need not send to the cloud. The entire information need not send to the cloud. Only that which is essential, only that which is very much needed, only that data can be transmitted. So by that way, you can use more efficiently the bandwidth and reduce the latency. And not only that, there will be not much pressure on our cloud. So we not need to have high-end clouds and a lot of space towards the cloud, because you have to pay more for that. So that is what we speak about edge AI. Then another benefit we talk about, some of the benefits. Obviously, I have spoken about something called it as low latency, or you can say latency, less latency or latency reduction will be done when we talk about edge AI. This because you're talking about the processing there itself, decision in milliseconds. You can do that decision if you are having high power computational systems at the node itself. This will be essential when you talk about one is the autonomous driving. Obviously, we can see Tesla cars are there nowadays. Mahindra also started with this little bit autonomous. Tata is also started with saying that parking free, reverse as well as parking can be done without human intervention. So that can be autonomous driving. Then we have something like industrial autonomy. So autonomy or automation is like industrial automation. Earlier, no, the industry was mostly depend on PLCs. PLCs were there, which Siemens and all PLCs were there. Uh, so the industry was using this PLC and control room. There will be someone who will be looking after this and all. But the moment the 4.0 industrial 4.0 came into across, the PLCs pressure has been reduced and this AI was implemented over there. So there is a possibility that we can use this into industrial automation also. And obviously healthcare. Now we can see even the cancer patients are treated with the robotic arms and all processing is done over there. So healthcare and healthcare monitoring, and we have smart watches and all, which will be taking the data from our heartbeat. And if any fluctuations are there, that can be done or informed in a very less latency. So these are some of the benefits, what I can say. Along with that, there are some more benefits. I guess one of the major benefit will be the privacy. See, need not send to the cloud where the data is stored. You need not store the data which is not required at all. By that way, what happens is the privacy will be there. You need not send the entire raw data. So that is a possibility. We can say that we need not send the data towards the cloud where everyone can access this, or almost everyone can check it out. And not only that, you don't want that images to be sent to the cloud. There is a possibility like that. When you are having home automation and all, where you have installed your cameras and all, you don't want to send because it matters your privacy also. So the raw data need not be sent. Only that specific data, like some intrusion happened, some violence happened. Only that recorded part, if we send, that is fine. remaining time, we need not send all that data onto the cloud and all. So, and not only that, say, for example, health information, that also people will say that the patient health is very much important. You cannot just publish onto the cloud and everyone can see that. Sometimes, it will be very sensitive information. So, like cancers and all, patient need not, will not find it easy to share the data and all. So that is one. The video feeds which I was talking about, that is the other one. Even the industrial metrics also. When you talk about industry, the people don't want to show how their industry work or how they have their hardware works over there, how the technology works over there. They don't want to show off that data onto the cloud. So they hesitated. So at the time, instead of using the traditional cloud AI, it is obviously selective that edge AI will be better for all this benefits what just now I spoke about. Now, for example, we say as a faculty, we can say that, okay, there are students who have written the assignment. I stay in Hyderabad and there's a college in Vijayawada, say, suppose. The assignments have to reach to me, then I have to evaluate it. And then once again, I have to score it and I have to send it back. This will happen. This will be, you can say, an example for your traditional cloud AI, that, a student is somewhere and the faculty is somewhere else, and you have to send all the assignments and all to the faculty somewhere else, and the faculty has to correct it, give the marks and send it back. So it will take a lot of time. At the same time, for example, the same faculty is available in the class itself, and you have the students have the assignments itself there itself. So it will take very less time to evaluate and give marks. So that is what we call it as edge AI. So you can differentiate like this, the difference between cloud AI and, edge AI. I tried because all faculty members are there, so it is a very possible example that I have tried to give. So that is how we can, compare the cloud with edge. So this is what this slide will talk about. Obviously, because our main intention of today's discussion will be about the latency also. So let us deal with this, call it as what are the different types of challenges that we have or we will see depending on the latency. Then that is how we'll be able to shift from, uh, cloud AI to our edge AI. So let us talk about it. Let me, if possible, mute this participant. Imran sir, if you can mute this participant.
हम अमल के लेते हैं 1.5 रुपए नीचे
Imran sir?
नहीं उसमें अच्छा है सो
Okay, someone is there and I cannot mute them. I'm sorry for that. The host has to mute them.
Sorry for the interruption,
No,
sir.
no problem. Sometimes happens, sir. It's okay. If you can possibly mute the other
Yeah,
participants.
I already muted.
Okay, thank you so much, sir. Okay, I'll continue with this. So we were talking about something called it as what are the various types of latency challenges are there, which will be, which will be making us to shift from cloud AI to edge AI. This is what we talk about. Latency will be the delay between sending the data, then we have processing it and receiving the response. In everyday application like sending emails or watching videos, or I gave example of washing machines, and you can go with microwave ovens also. At that time we don't require any latency into consideration, but there are some critical applications like self-driving cars are there. Nowadays it becomes a fashion of making the car itself to drive, so that self-driving cars are there, or patient monitorings when it comes towards ICU. That is also very much critical is there. So at that time this will be very much important for us to think about it. Even a few milliseconds can give us the serious consequences will be there. So that is where we will be talking about this. So let me start with the first reason for this. This is about round trip delays in cloud system, that is distance between the device and the server. Obviously it will be, data has to travel over the network to the cloud, get processed and written to the device. No matter whether you are having a high speed network, there will be always something called it as congestion will be there. Then we have something called it as packet loss will be there. Third one, we can speak about the bandwidth. Obviously, limitations will be there on the bandwidth, due to which there will be a lot of delays. And not only that, there is a possibility that multiple nodes want to transmit the same information also. So you have duplication of the information. Once again, each information should be processed and then it should be sent. So this becomes very, very difficult. And consider this all into a autonomous car, which is sending information saying that there is someone in front of the car is going around 60 kilometers per hour, and suddenly someone is there in front of it. Sensors are activated and they're sending the information that someone is there. The car should take left or right or stop, and that data is sent to the cloud. It is processing, and by the time it reaches the car for the decision to be made, already the accident will be happened. So this is what we speak about. We cannot use that because it is criticality is there. So this is the first, we can say, latency challenge is there. We call it as round trip delays in the cloud system. Let us talk about the second one. The second one, we talk about the real-time response. That is about your processing time. Obviously, it goes with the same way, saying that multiple requests came at the same instant of time. There is a network where you have temperature sensor, there is a fire sensor, some other sensors are there. There is a possibility that multiple criticalities came at the same instance of time. It becomes very difficult for the cloud to give the priorities and process it, because every information that comes at that instant of time will be having the highest priority. So everything has the same highest priority, then it will go towards deadlock. This will happen, and instead of giving any response, it will be just restart itself. So that is what we talk about, having multiple responses onto the cloud. You cannot simply send the data to the cloud and expect that response will come at the very fraction of second. At the same time, if all the devices are sending the information, then it becomes very, very difficult. As I told that, a lot of packets will be there which are in queue, and all those will be having the highest priority. So it becomes difficult for even the AI to compute when it comes towards the cloud. But Edge AI will definitely solve this problem, because you need not send everything data onto that. Instead of that, locally or the near device, which I talked about, near server, these can at least reduce the wait time, need not go up to the cloud, and they can process it and they can readily give the data without much relying on the cloud to be processed. The same way, for example, healthcare is also there. That is also one of the great example which you can give when we talk about why this low latency is required or crucial. We talk about ICU patients, vitals are very much important. Basically, when you talk about heart rate or oxygen level or blood pressure, this has to be monitored continuously. The moment you stop doing it depends on, say, that everything is autonomous, the hospital is completely automized. Then also it cannot be relied on it when you're talking about cloud, because it takes a lot of time and we require to monitor, and the patients are, abnormality will be there. That's the reason why they are in ICU. So you cannot delay it because it directly impact towards the life of the patient. Whereas, for example, we say that no, we are using Edge AI at that time. Obviously, it will analyze there itself. So critical condition or critical applications will be there where you can trigger the alarms there itself. So that is also one of the best thing where we can talk about the edge. So one is, as I said, about the autonomous driving, and second thing is ICU monitoring and all. We can add the industrial also, where where the steam is there and steam is burning, and it will be converted into electricity like that. And we need to specifically set what should be the water level into that, specifically set the heat, how much heat we need to give towards it. That is one of the example where we're talking about. So it will take a lot of time. So that is the reason why we try to reduce the latency. It's like if we see this chart, you can identify how much of delay it will take or how much time it will consume. This is like we have two things: one, writing the data, and reading the data. So if you take edge, read and write, you can see in green color, you can see the values are very, very less, like 10 and 9.83. You can use that as a milliseconds factor compared to the cloud. If you are doing with the cloud, write and as well as read, where the network is also really good, at that time there is a possibility of lot of latency is there. You can compare directly. You can see a lot of difference is there when you talk about the latency compared to edge versus cloud. So this is where we will be talking about low latency is required. Then high reliability will be there. People will be trying to use those. So whenever you talk about high reliable applications, we'll be talking about the low latency. So this is what we can come out of this latency challenges for this session. And let us talk about the various edge AI. Now we will deeply go into this topic of edge AI with the collaboration or integration of IoT architecture. So this will be talking about, right now I'll be trying to use this session because this is the most important topic about combining the edge AI and IoT architecture. And by now, everyone might have understood what is actually the edge AI is and what we can use that in IoT applications and all. So let us start with this. Now, first of all, we'll be talking about something like, obviously we talked about reduction of latency and system performance can be improved and all. So the first part which we can speak now regarding is the IoT devices with onboard intelligence. It's like it is the first layer, or you can say that this will be the bottom layer, where the sensors are there, activators are there, wearable devices are there, cameras are there. Unlike we are talking about, unlike the traditional, where we'll take the data and then we will send to the cloud. But not only that, that is a traditional way. So we're not talking about traditional now. We'll be talking about something called it as onboard intelligence, meaning that we will be having AI placed on the device itself and make sure it detects anomalies, detects someone is coming, intrusion is there, or depending on our application, whatever it is. We try to use our AI models onto the device itself and try to provide decisions instantaneously. But there is a problem. The problem is that we cannot integrate the entire AI onto our device, because obviously we know that IoT devices are, very small in size. They lack in capacity. They lack in the power. I mean to say power storage. It will be very less. Power consumption will be more when you are integrating AI onto the device. Device might be taking very less, energy. The moment you start AI into that, it takes tens or twenties or times of the energy that is being consumed. So that is what we talk about. And not only that, sometimes overheat will be taking place. All right, that we'll talk in few minutes. But for now, we say that okay, then what is the remedy of it? I hope as a faculty we all know, when you are working on IoT and all, there is like Raspberry Pico and all, or Zero board we call it as. At the time, we don't install the entire Python like we have in Raspberry Pi. Instead of that, what we do is there is something called it as Thoni, where only selective Python libraries will be there. And if you want, you will install those libraries or download the libraries, but still Python will work. It has very less space. So instead of that, using the entire Python, we'll be using tiny Python. The same way, we will not use the entire AI, but we will be using something called it as lightweight AI. It means that little amount of AI can be introduced on the board itself, depending on a specific application. It cannot be all applications, but it can run on a specific application. Like for example, say smart watch is there. I want to integrate my AI. Obviously, when I integrate with AI, it consumes a lot of energy. So what I do, I'll use the lightweight AI such a way that I'll use only for, say, heart rate. Whenever there is an irregularity in the heart rate, it will execute the decision making and it will give me instant result. So that will be a very, you can say, specific way in which I can explain about using the lightweight AI. So that will be, practically possible because of less space and less, consumption of energy and all stuff. With taking IoT into our background, we'll be using the lightweight AI. And not only that, there are some applications where it becomes very difficult, when we talk about industry or in the vehicle itself, when you run the motor, the energy will be, overheat. There are some sensors which will not work at all. At the time, it will shut down immediately and all. So the key point, what I want to tell you is there is real-time decision making can be possible at the source itself if we integrate, or we can say if we have the device along with onboard intelligence. Earlier days, we used to transmit the information, but right now we will try to incorporate this intelligence on the board using lightweight AIs. So with that, you can make the real-time decision very quickly. Second thing is we try to, okay, there is a possibility that we need not to have IoT boards which has onboard intelligence. Second thing is some places where you may not have onboard intelligence. At that time, what we can do is we'll connect these nodes to a very much near way gateway, or we can say edge server. So that is what I guess earlier also I was talking about. So we can have the edge servers also. Which will be talking about edge servers, and these will be providing us as a gateway which is closer to the device. That means that it need not be onboard intelligence, but at least there will be specific server, which when you say specific server, we can have a good power supply to that, good energy towards it, and it can have little bit more computational possibilities compared to onboard intelligence. It is like second powerful version of it. So you can use edge server. We can try to get this edge server connected to it. Like for example, you speak about traffic congestion is there. So at the time, there is a possibility that, along with this, say the traffic light is there at a junction. Within no time, another junction is there is also another traffic light. Sometimes we feel that we are going in a route. First lights were green. We cross that, and immediately there is another junction where the light is red, so you have to stop for twice. Whereas if we use AI and try to calibrate the the traffic lights, obviously, once you get a green after say 1 minute you're traveling over there, at that time if there is a possibility that it switch on to the green, so wait time will be reduced. So instead of waiting for two junctions, you need not wait at all. Once the first junction is over, automatically, if it is a straight road, they should get green color. So that is where we can connect all these traffic lights onto one specific server, and we call that as edge server, or basically we say edge gateway, and it will be having more intelligence on it. So when you say a little bit more enhanced applications are there, at the time, instead of going with onboard intelligence, we can go with edge servers. Then the third one we talk about, the most important, I can say that, is the adaptive antennas. Nowadays, we are getting this type of adaptive antennas, which are smarter and which are intelligent, which, no, the way it has been architect, it can adjust the beam width, the beams which dynamically used. So that is where this type of reliability will come towards the adaptive antenna. Because when you say adaptive antenna, usage, I can give example as the vehicles which are moving. At every vehicle, you can see like it will be moving around 50 kilometers per hour, 60 kilometers per hour, and you should be able to connect those. So that means that high quality connection is required between the vehicles, or vehicle to infrastructure. So at that time, to maintain stability, the connectivity should be very much stable. At that time, instead of using the traditional antennas, we can use this adaptive antennas where dynamically the beams can be changed, but dynamically, radiation pattern can be changed. This will be very much helpful when it comes towards autonomous vehicles. So this is the third part, which call it as adaptive antennas for reliable connection. And obviously, you have the connection, like we integrate into the smart hospitals and all, where you can have edge servers in the hospital, and all the devices are connected. The IoT devices are connected. You can use these three different, like either having onboard intelligence, or along with that having the edge servers. And To that, as an add-on, we will be try to use our adaptive antennas. So that is what we will be talking about. So you can also think about like having the healthcare or industrial. So when you speak about healthcare, we can talk about the ICU monitors or wearable health trackers. So these all can be connected to the edge servers, and then we can have the most intelligent over there. And sometimes we can use our onboard also. So onboard, like when you talk about industrial, onboard will be very much advantageous compared to the rest of it. But when you talk about traffic lights or the hospitals, not a simple ICU room, but majorly a hospital, at the time we can implement this edge servers. So there is a possibility either you can have onboard intelligence or edge servers. And when it comes to the vehicle communication, we will be trying to use this adaptive antennas. So that is what we talk about. A little about the adaptive antennas, I just wanted to tell. Basically, we talk about the beam forming and MIMO antennas, multiple input and multiple output antennas, where latency will be less. But the adaptive antenna speciality is it will be able to dynamically adjust the direction uh, and shape their beams. Even the beams can be changed depending on the specific selective device. So at the time, it will be very much useful for us because the connectivity will be there. So you can say quality of service will obviously will be increased when you're talking about it. And the channels can also be switched. There is a possibility that spectrum sensing is also be done with this type of antenna. So it will be very revolutionary antennas that will be available right now when we talk about 5G mobile phones and 6G. Still, we have using the strip antenna, but we are integrating it, meaning the technology has been advanced where we'll be having this AI assisted antennas also. That in near future, like in a year or 2 years, I guess in our mobile phones also we'll be finding not only AI assisted mobile phone, we'll be able to find AI assisted antenna tuning also. So that will give us very edge way of connecting through other devices where our beam forming can be changed. Obviously, DSP will be used in that, and obviously this one is also important. We speak about real-time spectrum sensing also. So this is one of the key research areas nowadays. Those who are working on antennas, along with that, if there is a possibility, try to use this type of antennas, call it as adaptive antennas, which gives an extra edge towards compared to the traditional antennas. So that is what. So quickly, let us deal some case studies. Actually, I thought of discussing it. Like as already I told that I want to discuss in three different major areas where this edge IoT, edge AI and IoT are connected or integrated. That was, I guess, if you remember, one was the healthcare, second one was about the vehicle communication, and the third one is about the industrial application. So at least we'll try a little bit about the healthcare. Obviously, I have already spoken about more about this wearable devices. Nowadays, everyone has the digital or smart watches, which are wearable devices, and they will be giving our SpO2 or blood pressure and vitals like temperature also, and it will tell about how much walk we have done, how many steps we have done. And sometimes there are critical cases also, like for example fall detection. Nowadays these wearable devices are coming with fall free, or you can say when a patient is going to fall, it will vibrate such a way that the consciousness will come, or still it is falling, then the buzzer will go on. So that is how nowadays we are trying to work with the AI, which predicts the detection of fall in milliseconds, or sending the alert message to the hospital, or some or the other way. We are trying to get the predictive AI onto the IoT devices, that is wearable IoT devices. This is where edge will work a lot, because we have to give instantaneous decision making should be done. As I told, fall detection and cardiac monitoring also is very much required, and these variable devices will reduce the latency, and by that way patient safety can be increased. So this is where one of the case study we have taken, that edge servers will act very much strongly, and the results are really good when we talk about using the edge AI compared to the traditional cloud AI. And some of the real-time examples are like fault detection, cardiac monitoring, ICU alerts. Sometimes, doctors can remotely check the patients also. So remote patient checks and all. So that is what we talk about. So this is what the first case study, what I want to bring into your notice. The second one, obviously, we talk about industrial 4.0 as well as 5.0. Nowadays, robotics has came into existence. Maximum industries works on robotic arms. At the time, we can have an option of having the edge enabled robotics. Doesn't matter, starting from baking a cake to to go with maximum extent, where all the industry, instead of depending on the humans, now they are converted into robotics and all, and because maintenance and all. So that is one, edge-enabled robotics have came into existence where AI can be kept on the robot hand itself such that it will do the things in a proper way, or the conveyor belt is there. Depending on the number of products that are there, it can increase the speed or reduce the speed. Nowadays, Amazon facility, Flipkart facilities are using these. So at the time, we will be using this edge AI directly, and there is a predictive of the maintenance and all, which can predict, saying that there is a possibility of something is happening before it actually happens, and it will stop such that minimal effect will be there onto that. By using the milliseconds, in milliseconds you'll be able to address the issues that comes over there. So that is what goes with the safety, quality, and the efficiency in very short period of time. So that is what we talk about the industrial 4.0, where edge AI will be connected with IoT to enable real-time automation in factories, uh, and reduce, obviously the cost will be reduced. High quality production will be there, as well as it will be reliable to communicate, and trust can be maintained when it talks about edge. And the third important was about the autonomous vehicles, which, latency and all, as I was speaking about. We have something like vehicle communication, onboard vehicle communication, vehicle to vehicle communication, vehicle to infrastructure. So we say it is like vehicle to everything, where we have lot of applications right now in the market. We boost this. There is lot of engineers required when it comes towards edge AI with autonomous vehicles. Even Mahindra 9XE, which they have introduced, even for that also there are so many drawbacks that are coming in a real-time application. So they are upgrading the systems, and they required really the technicians to work on that. So if there is a possibility now, we have to work on this edge AI towards the autonomous vehicles, such a way that we can support the industry also, as well as make our students also to get placed into those companies also. That is also one of the beautiful domain in which the students can contribute, and you can also contribute. Students can learn from that and get placed towards it. There's a lot of scope in this. So because we required ultra low latency, it will be should be in very, very less milliseconds in that, because autonomous vehicle safety is very much required towards it. So that is what I was talking about. Obviously, like obstacle detection and decision making, that is where we required this critical reliability should be there, and low latency should be there when it comes towards the dense environment, because your car is not the only car which will be driving, which has smartness in that. There are multiple cars, and at the same time lot of data will be communicating. So we have to distinguish with that. So that is where I was talking about the antennas. The adaptive antennas will come into existence. So that is the third one. This also have a lot of scope in that. So try to work and focus on these three streams where edge AI will have a lot of impact towards the IoT applications. Now, let us obviously we have to talk about something like challenges also. We cannot simply say that okay, AI is integrated and our system starts running into it. Now, there are so many challenges in edge AI to be implemented on IoT. Yeah, very much. You cannot simply say that, okay, we can achieve the low latency and no real-time intelligence there itself on board and all. It has a lot of challenges also. Uh, First, let us talk about the challenge which uh, basically works on our IoT devices is processing power for the devices. If you keep edge on board, it takes a lot of energy, as I told. Power is required. But there are so many IoT applications where power is minimum. Limited CPU will be there. Even now, I guess majority of us will be talking to the students saying that let us have Node MCU to run the devices and connect it to Wi-Fi and all. We are not in the stage where we'll have high end like for example high end Raspberry Pis, Raspberry 5 or at least like that, or Jetson controllers which will be used. And not only that, the I was talking about the AI, the same way we'll be having something called it as tiny ML machine learning, which is a tiny machine learning, or pruning that is also there, where pruning is also acts as an important part of AI model, where we will be trying to use only those nodes which are required, remaining will be removing it. So pruning is also one of the important constraint. So that is what I was talking about. Limitation is there towards the power, or at the devices end when you are using onboard intelligence. Second, obviously, the energy constraint is also there. So when we talk about energy, just a second. There's something linked, please. Okay. So the next one we will be talking about the limited processing power and energy constraints. And the third one is about the security and privacy. Say suppose we have kept a high power, Raspberry Pis and all onto a place where no one is there and we kept it to detect it. Someone comes and rob that. Then there, there will be a lot of damage compared to. Instead of that, you might think that, array, instead of that, Node MC would have been better over there if it lost around 300, 400 rupees loss is there. Instead of that, we kept Raspberry Pis and they took all our Raspberry Pis. So this also will be happens, attacks will be happen, and rough environments will be there. At the time, it will become very, very difficult. Then at the same time, so that is what we talk about the third one, where we will be speaking about the security and privacy issues are there. Then there is another most important gap. We call it as standardization gaps. See, Edge AI just now started. Edge AI with IoT has collaborated now, but it will take a lot of time to make our protocols to match. That is also a big challenge is there. Obviously, when we say MQTT is there or 5G standards are there, 6G standards are there, these standards are based on the cloud AI, not on edge AI. So it will take a lot of time also to develop these layers onto the edge AI instead of traditional cloud AI. So that is also there. So standardized gaps also will be there. So these are the various challenges which I have observed and want to bring to your kind notice about that. And now, as I was talking about this, research directions are very much important. For one is we can tell our students also to do some projects on that, and then it's our faculty also to enhance the skill set. And there are some faculty who want to do their PhDs and all, and looking for the research domain and all. Obviously, it will be very difficult to the faculty to select a research domain. For them also, this will be very much helpful. We have something like AI models, compression, where I was talking about reduction of the size of it and use it for IoT. So many can work on this tiny machine learning. And I was talking about pruning also. Like we don't use the entire what you can say the AI model. Instead of that, we'll be try to remove some part of it. So research is going on a lot, like ultra small AI models that can be done using the tiny machine learning. And already I told that pruning is like we have weights and models. So it will be try to remove unnecessary weights in the size such that accuracy can be increased. At the same time, memory also will be less. So it can save the memory. So this is one of the important, you can speak about the research that can be done on that, tiny edge devices and all. Then obviously with respect to the federated learning also, like AI with centralized data for training, then having the privacy of it, bandwidth concerns are there. So we can train the devices instead of single device. There is a possibility that multiple devices locally can be trained using AI model. So that is also another research area where there is a possibility of working on it. Like instead of training one single device, at the same instant of time, there is a possibility that multiple devices can be trained locally. So this will be the second example, like healthcare and all. This will work into picture. Third one, obviously, we talk about energy harvesting. This is also one of the booming technologies where the research is going on. So those who work on research try to do the energy harvesting. Basically the normal techniques are like solar panel will keep it, or the RF energy that can be used to get that. Because we say if we use edge AI to decide at what time which one we can use, like sometimes we'll use RF, sometimes we'll use thermal, sometimes we can use solar. By that way we can use, or real time decisions can be made which one can be used without replacing the batteries. So there are some uh, places where every time it is very difficult for us undersea, or somewhere in the forest area, it becomes very difficult to go and replace the battery. So at that time we'll be trying to use this energy harvesting. And obviously, the last one we talk about this edge AI in 6G. Because I was talking about 5G, there is no much layers that have been mentioned for edge AI, but it has been mentioned for more towards the cloud AI. But nowadays, you talk about, as I was talking about, there is a possibility of using our adaptive antennas or reconfigurable antennas that can be impacted on 6G. So those who are working on antennas, they can work on this type of 6G reconfigurable antennas, where we can use for adaptive based. And this will be work basically on to vehicle to everything. So vehicle to vehicle communication and all. So those who are looking after it try to focus on this. And not only that, in the next, because as we faculty, we need to think about even the funding opportunities also. So I thought we'll have one slide on this, discussing about Edge AI. With one is the collaboration with AICT. Right now, the RPS, which is called it as a research promotion scheme, they are granting innovative research projects on just now what all I have discussed. If you have any ideas regarding it or want to work on that, AICT is boosting towards the grants, towards the innovative research ideas, and particularly health monitoring. Vehicles, of course, you can directly go with the industrial, but when it talks about health monitoring, a lot of focus is there. So one is the AICT. Second, obviously, DST will be there. There is a special program that is going on where they are collaborating IoT with AI. So this mission program also want, these people want it for traffic light signaling. So that is one, and agriculture. So DST will be working on this. So if at all anyone want to grab the opportunity, they can try with this. Then I guess SERB will be there. Huh. This also goes with the core, 6G. They are working on this 6G. Energy efficient AI models can be introduced on IoT wearable devices. So there is a lot of grants on that. And Ministry of Electronics is also there, and Ministry of Electronics and IT. These also looking towards the prototypes and startups of AI collaborated with IoT. So we can work on that. And obviously the last will be MSME. You can see a lot of MSME initiative programs are going on, where IoT startups are there. They are encouraging the IoT startups which uses the edge AI onto them. So that is, another funding opportunity also are there. So not only research, you can have the funding opportunity also when you talk about the edge AI and all. Pedagogical relevance, it's like how we can make our students to understand this and how we can introduce into our curriculum. So this is what I was adding this, saying that in our curriculums also, if we have autonomous colleges and all, we can add this type of technologies into our curriculum. I've seen in Andhra, a lot of colleges are there which are EC with IoT also. Here in Telangana, we see only computer science with IoT, computer science with data science. But it is good habit that we have in Andhra Pradesh, saying that EC with IoT also collaboration, EC with machine learning. That is a very good way initiative, I should say. By that way, EC is also going ahead compared to the computer science, unlike in Telangana, where majorly they are focusing only on CSE. So this can be integrated into our curriculum. And second thing is installing the labs and all. As I was talking about Raspberry Pis or Jetson, this is where we can incorporate our edge AI, at least for simple real-time temperature monitoring or something like that, where latency can be improved or that. That is how. And obviously the projects work, the final year projects can be done on that. And interdisciplinary research is also very much interested, where you can connect these students also into join from various departments and you can work on that. So that is what the relevance is all about. We will try to have this, if cloud goes offline, how can edge AI keep on IoT functional? So say suppose internet is off, but still there is a possibility that edge AI can work on to the IoT. So it is not needed that everything should be dependent on it. It's like, for example, we can say local interface at the edge, because that is how we were talking about. Then temporary data storage and caching is done. Then we can try to go with the peer-to-peer communication. And so we can use the AI servers only at the edge rather than installing them onto the cloud. So this is how we will be talking about this whole concept of. And obviously, I was talking about the future trends, where 6G can be used over there. A lot of 6G can be done. And then the IoT, digital twins are there. Like instead of completely physical, processing can be done with the IoT devices. Simulation can be done, prediction can be done, or we can say automation can be done. Third one, we speak about the adaptive antennas as I'm talking about. This is also another futuristic option where we can try to work on that. So along with that, industry also. So I guess that is how our session goes with. And already I told about what will be the takeaways from this discussion is about. I guess one is about the minimizing the latency. That is one of the key takeaways for today's session, where edge AI is basically used to reduce the latency. And as I was talking about the adaptive antennas also, which will be providing the reliability on that. And not only that, there are vast research and teaching opportunities existing in this domain. As I was talking about, wide applications are there and a lot of funding can be done. So that is what from my side for today. And I guess I have justified towards the title that has been provided for me. And I thank the organizers as well as the principal of the college for providing me this opportunity to speak a little bit, and share knowledge on these three domains, but basically edge AI with the collaborated with IoT devices, and majorly focus on the lower latency communication systems. I once again thank our Imran sir for giving me this opportunity to share my knowledge that I have. And I should thankful to the Department of EC as well as the principal, Dr. K. Sudhakar sir, for providing me this opportunity in this ATAL online FDP program. Thank you, one and all. Thank you, participants, also for listening to my talk. Thank you so much.
Thank you very much, sir,
Yes,
for
sir.
enlightening all of us with more productive and interactive session.
Thank you, sir.
Your presentation has really highlighted the role of IoT devices, artificial intelligence, adaptive antennas, and edge computing in enabling next generation low latency communication systems. The insights you provided will undoubtedly benefit our participants in designing future ready IoT solutions. Gaining not only technical aspects, but also in the research perspective also. But one thing I have to mention, sir, at the very beginning, you mentioned that you had been asking to be a part of this FDP because of your interest in the title. But, sir, I must say, you are actually a special invitee to this program. Indeed, a very special to me also, as it has been our privilege
Yes, sir.
and honor to have you with us today.
Thank you so much, sir. Thank you.
Your session has really inspired us with new ideas and directions, and we look forward to many such interactions in the future also.
Sure, sir. Sure. Thank you so much, sir.
On behalf of the Department of Electronics and Communication Engineering, sir, and even from the participant side also, I sincerely thank you once again for sharing your quality time, knowledge, and expertise with us.
Thank you, sir.
Thank you very
Thank
much.
so much. Thank you, sir.
Thank you very much, Rahim sir.
Thank you so much, Mahbub, sir. Thank you.
Thank you, sir.
Sir, shall I leave the session? Can I?
Participants, you are requested to ask any questions. If you have, please clarify with the subject expert. Thank you, sir. Thank you once
Yes,
again
sir.
for
Thank you
spending
so much,
quality
sir.
time with us.
All right, sir.
Thank you very much, sir,
Thank you.
Rahim sir. Thank you, sir.
Dear participants, your feedback and attendance link is in the chat box. Please fill it. Session 6 is about to start in a couple of minutes. Till then, please fill the feedback and attendance link for session 5.
Respected. Good evening to respected
Dear participants, now we move on to the session 6 of this 6 days AICTE Faculty Development Program. For this session, our co-coordinator S. Mehboob Basha sir will be taking charge and he will be guiding you the remaining proceedings. Mehboob Basha sir?
Sir, my voice audible, sir?
Yes sir, you please take over the session sir.
Yes, sir. Thank you very much,
Please
sir.
invite the resource person.
Good evening to our respected college principal, Dr. K. Sudhakar Garu, our HOD Madam, K. Suvarna Madam, and Program Coordinator, C. P. Imran Garu. It's my privilege and honor to welcome all the participants to today's second session of this faculty development program. This moment is very special as we are joined by our distinguished resource person, Dr. V. Muhammad Dada, who has kindly accepted our invitation to enlighten us with his expertise. Now, coming to brief introduction about our resource person, Dr. V. Muhammad Dada is currently serving as a founder and CTO of SNAR Technologies Private Limited and has an extensive background in the area of Internet of Things and working knowledge in AI sensors. With more than 19 years of academic and professional experience, he has contributed significantly in the areas of R&D activities, industry collaborations. We are very truly fortunate to have Dr. V. Muhammad Dada with us today to share insights on AI-based signal processing techniques for enhanced wireless communication performance, which I am sure that this session will be thought-provoking and highly beneficial for all of us. Thank you. Now I request our resource person to continue the session. Sir, Muhammad sir.
Sir, thank you, sir. Thank you very much. I will
you,
take
sir.
care, sir. No worries.
Okay, sir.
My voice is audible, sir?
Yes, sir. Audible, sir. Audible, sir.
And okay.
Yes, sir. Audible, sir.
Great.
Muhammad sir. Muhammad sir, are you available, sir?
Mehboob Basa, sir.
Sir.
He will join in 2 minutes, sir.
Okay, sir.
His laptop got shut down.
Okay, sir.
All the participants, please bear for two more minutes.
Okay, Imran sir.
Dear participants, who have not filled the feedback link, please try to fill the feedback link.
Sir, my voice is audible, sir?
Yes, sir. Audible, sir.
Right. Sorry for disturbance.
No problem.
Actually, my laptop got in trouble. Right.
Yes, sir.
1 minute. Let me take it back. Mahmood Basa, sir, my voice and
Okay, sir. Everything is audible and visible, sir.
visible, right? Done, sir. Right.
Yes.
Sorry for disturbance.
No problem, sir. Please carry on, sir.
I really thanks to our organizers who gave this opportunity to interact with fellow faculty members, because I too worked as a faculty member for 14 and a half year, and served as HOD for in EC department. I have a great concern regarding to faculty members and the sharing of knowledge with faculty as well as students wherever I find time. And we regularly are visiting many engineering colleges across our India. Um, uh, when I was working in university, I interacted some fellow the faculty members and only limited students. When we then we started our startup company like Asnar Technologies Private Limited in Kurnool, and we are working with cutting edge technologies like IoT, AML, and robotics. And we are marketing, we are manufacturing here only, and we are selling our products in abroad also. And so I visited many engineering colleges and universities across India, so that wherever I have some time, I will interact with students as well as faculty. It's a great experience. Today also, really happy for interacting with all faculty members who have around 87 members are there from different colleges. This is a time we can share our knowledge, what we are really doing in industry, and also what we need in as experience or in practical manner, whatever we are doing or whatever we learning, we need to put in practical manner. So then only we'll get the good results. Even though for our future enhancement or improvement, as well as for students and scholars also, it's very helpful. Wherever we find, we need to demonstrate, and we need to put our experience in practical concepts. So in this regard, I thanks our organizers, our Imran sir and Mahbub sir and principal sir, and we have a great interaction with this St. Joseph St. Joseph College of Engineering and Technology. Our Narasimha sir also have a great friend to me. And today, this very burning subject, that is AI, IoT, one minute. Integrating AI, IoT, and adaptive antennas for high performance communication systems is a great subject, because see, we integrated many technologies like AI, IoT, and adaptive antennas. So, as you all are faculty members, we have great awareness about the communication systems. Here, I'm not here for discussing the communication, what are the standards and what are the different techniques we are using. But in very recent year, we have a tremendous changes, and also we have a very great technologies are emerged in form of AI and IoT and adaptive antennas. So here so these are changing entire each and every field touching AI and IoT. Is not a particularly one subject, is not a particularly for one group of people. So this AI and IoT is for all. So the same thing we used to say in wherever we go. So this time we are not confined for only one subject. So we want to learn each and everything, because applications demands the subjects. Applications demands the subject, and applications are involve diversified subjects. Is not only one particular subject. So in this regard, the government of India is also to initiate to start different concept, that is IIIT DM, design and manufacturing. So nowadays we need to have a complete knowledge to make one product. In this manner, we are very much interested to learn this AI and IoT. Of course, IoT is a remote accessing technology, but AI touches each and every field. So far the AI, the many data scientists think that the AI is only for data processing. So now the many applications we are working with the AI is only data processing in stock market, in somewhere in YouTube analysis. So there we are implementing an automation of applications. Automation of applications we are meeting with AI. So, but when I was in starting with faculty, I thought that the AI will touch each and every engineering applications. Each and every engineering application is not only for one particular subject, is not the subject of computer science or any data science. So it is basic requirement for all subjects. So wherever, because each and every faculty and each and every person have the expert in their subject, because this the communication have the great knowledge, and someone have the great knowledge in sensors technology, and someone have great knowledge in IoT, the remote accessing, the protocol, network protocols, like many fields, they are expert. But we need to integrate AI, this AI, because AI changing each and every field. So we are making our systems, our whatever we have the routine works, those routine works we are improving, we are making better performance with AI, because AI is a dynamic, is not a statistic. I mean, it's not a static. It's not a static one. It is a dynamic, and it gives the dynamic solutions, and it gives the better perform for each and every field. It's not only for communication. Now we are talking about communication, wireless communication. How we need to perform, how we need to make better our performance with AI. And so now we are talking, but each and every field touching this AI. So this is AI is mandatory for each and everyone, where we are reducing the analysis part, and we are reducing the human interference, and we are reducing the cost also, and we are enhancing the uh, speed of results. We are enhancing the performance. So that's why here also the Imran sir and their team chosen very great title, that is integrating AI and IoT. Of course, IoT is a remote technology, so application. So IoT is an application, but AI is a part of that application. So we need to improve, we need to serve for IoT technology, we need to serve for IoT technology with AI and adaptive antennas. Adaptive antennas and AI will make better performance of IoT. So already I joined last session 10 minutes before I listen. So wherever we go, we are talking about edge computing, AI, and lightweight protocols. So these are very interesting and also very what we called very emerging fields, because so far we have some basic applications where in communication or wherever we are using the communication purpose, but now the applications are emerging, applications are demanding these subjects, demanding the speed, speed and demanding the uninterrupted communication. So in earlier, where we have some different types of communications, And so now we are enjoying with the seamless interruption of communication. But in future, this communication is also not sufficient, is not enough. So that's why the people thinking about how to enhance, how to give the better performance what we have right now we are using, because the each and every field has their own what we call functionality. So but there are some block spots, there are block spots, and where we are not addressed so far. So in that areas now we are addressing with AI. So it's not possible with manual operation, and now we are addressing those block spots, so that we'll improve the our sessions, improve the our what we called our wherever our subject is there. So that subject we are improving, and we are giving the better performance. As part of this wireless communication is also that this wireless communication is also, so wherever we are talking about the data latency, already sir told in last session, data latency and what we called channel selection. There are many things are there in communication. Those data latency or any other fields, wherever the challenging factors are there, the bandwidth issue and the speed issue, the error correction, there are many things are there fields. So those fields now we are addressing with AI, addressing with AI. And the beauty of this is it is very cheap. So if you know the Python, if you know the Python, with the Python we can make wonders. And also, actually, as we all are subject experts, so that we know each and every what we call the problems, and now we have generative AI tools available freely. So once we are familiar with the problem, and once we understand the problem, that problem we can write the programs very easily, and we can implement each and every problem in real world. So now this Python program we are using because it is very easy to implement, and we have hardware is also available in market at very cheap manner. Like already saw discussed about the some microcontrollers and Raspberry Pi, like Jetson Nano. These are the some very cool devices where we can implement all these algorithms. So here I am very much keen. I want to stress one point: is AI is for all. We want to adopt that AI for our subjects. That's all. So that we can improve the our, performance of our systems. So that is the I want to speak out here in this session. So for that, what are the some different techniques we have readily available? Is not a difficult task. So here I would like to mention one word. Whatever we are thinking, whatever we are doing, this is not a much difficult, because with Python we have only 3 or 4 lines of coding. That's all. That too we don't need to write the program. So if you give the problem for ChatGPT, it generates and it gives. So the only thing is, because as we are thinking about the productive, so we are in industry, so that we are always thinking about productive. So how fast and how better we are producing the products, and also how to finish the work. So for that we are implementing this Python and ChatGPT, and these cool softwares are there, and the hardware is also available. So very fast manner we are implementing each and everything. So like that we each and every one we need to learn these AI models. And there are only fixed models are there, around 10 to 20 models are there. So we can address for each and every problem of with these models. So in that the basic knowledge we need to know about AI and how to implement. So this what we called this IoT and adaptive antennas, this is a different one, but here we are going to what we call we are discussing about more on AI. So today we are going to discuss about these things. These are the course. The program outline. The introduction, the basic of AI signal processing. That is AI versus DSP, and supervised, unsupervised, reinforced learning role in wireless communication. And for examples for AI noise reduction versus the traditional filters, and core AI techniques in wireless signal processing. And that too, we are implementing this DNN and CNN. So the DNN, CNN, and ANN, this is not only for image processing. Wherever we required, wherever we need, these algorithms will work, right? Next, we'll go for applications in wireless communications in 5G, 6G networks, AI-based beamforming, interference, and cancellation, IoT networks, AI for energy efficiency communication, and cognitive radios and MIMO and massive MIMOs, and securities in AI for jamming detections everywhere. And later we'll go for practical approaches, that is data sets. Radio ML data sets are there, deep signal data sets are there, and synthetic wireless data sets are there. And the frameworks are we are going to use TensorFlow, PyCharm, or MATLAB. So MATLAB, that is also we are not using in our industry, MATLAB, but we are mostly we are using this PyCharm and what we call this TensorFlow and PyCharm we are using, and we have other the Python tools are there in virtual machines are available in online, that is VS Code is there, and Anaconda. These IDEs we are using, and GNU radio and SDR, software defined radio, and simulation with MATLAB or Python. We will going to see how we can. And so here you see this data sets, radio ML and deep signal and synthetic wireless data sets. So these data sets are very important because in ML we are implementing in any process like signal processing or any image processing wherever. So the data set plays very crucial role. So whether we can make ourselves or the readily available data sets are there, those data sets we need to take, and we need to understand the importance of that data sets. Because in ML, I will explain one thing here. In ML, this is one, the basic the basic steps are there. First is we need to take data set, and that data set we need to split into training data set and testing data set, and then we need to implement whatever algorithm we need to implement based on our requirement, and that algorithm we need to implement. And then when after getting our results, we need to validate those results with again we have algorithms for that, and we need to test. So these are the three main core what we called core steps in ML, I mean AI or ML. So that is one, data set is very important. Then we need to choose the appropriate algorithm. Then we need to test that results with we have already predefined algorithms are there. With that we need to check out. So like that, this is the flow of data. I mean the AI data. AI model, if you want to make one model, so in model, data set and algorithm, then we have testing, performance testing. So these three steps are very important. In data set also, if we need to split this data set into two types. One is trained data set and testing data set. So this is the basic what we call framework, or you say it is a steps, you say it is any one-to-one solution or end-to-end solution. Wherever if you want to implement any one model for your work, whatever work is up to you, right? So if you want to implement that one AI model for your work, so these are the steps. You pick up the appropriate data set, and you pick up the appropriate algorithm. We have already told 10 to 20 different types of algorithms are there based on supervised, unsupervised, reinforced, yes or no. These are the three different primary algorithms are there. So with that algorithms, we can choose appropriate one, and we need to make testing. So these are the basic things. I will explain later. I will show you. Right. Then we'll go for practical approach. Applications in 5G and 6G. These are the IoT, right? No issue. And practical approaches for data sets. Then we'll go for hardware. What are the different hardware? Already, I think last session Sal discussed about all these things. This is a Raspberry Pi and Jetson Nano, all these things, no issue. And hardware in that later we have implant and real world implementation. Telecommunication companies on data base, I mean AI in base stations, AI in smartphones, and research labs using AI for spectrum sharing, and the current trends in the future decision, I mean directions are AI in 6G and beyond, terahertz communication, AI powered edge intelligence in wireless, and quantum mission learnings, QML. So last time I attended the government meeting in last the couple of weeks back with all VCs. So there they are discussing about quantum mechanics, I mean quantum computing. So there they are talking about 4 different applications regarding to quantum computing. In that, quantum computing is the one I mean one area for address we need to address. And second is quantum communication. The quantum communication is also one thing. The communication is also another important field they chosen, the quantum communication, because now we are using this communication with what we have, but already the communication happening with atom to atom, I mean atom to atom, that then we need to establish, and if it is possible, so it is also next level of communication will happen. Next level of communication, the atom to atom communication, that is entanglement, or they are discussing. So this quantum communication is also one field they are talking about, this government of Andhra Pradesh especially. So quantum communication is also one emerging, it's not emerging, we need to go for that, and we need to work out for that, and how to communicate atom to atom. So that is also one field. And next is they're talking about quantum sensing and quantum materials. So these are the 4 different fields they are thinking, and they need to promote in Andhra Pradesh, especially in Amravati. So these are the some fields, and they are also ready for giving some funding with ATAL. I mean, Ratan Tata hub is there in Amravati, Vizag, and Anantapur. So with that also they are promoting these terms. And also recently the government of India also launches one program for establishment of quantum labs. Regarding to that, they are giving 1 crore of rupees for lab establishment, and one establishment. In that 50 lakhs for lab establishment and 50 lakhs for maintenance. So in that also this quantum, the communication is the one major field. So this is also very good. So like this, the quantum machine learning is also for signal processing, AI for green wireless and self-healing and self-optimized networks. And at the end of the day, AI is revolutionizing the signal processing and faster adaptive intelligence wireless systems, and opportunities for research and industries I already discussed. The practical demos for the Python example, I will give one Python example in with Colab, the Google Colab, so that very easy. So easily we can implement these topics. Right. So why we are using Python means, so this is the beauty of Python. So we can make different types of flow charts, graphs, whatever we need, so we can make with Python. So that is the two, that is, those are very effectively it works, and also it is free of cost. So in that, we need to learn AI models like NumPy, Pandas, scikit-learn, and TensorFlow. So these are the some libraries we need to know about when we are going to implement these AI models for any applications. So this wireless communication also, if you want to do something with AI communication, for
Excuse me,
communication.
Mohammed sir. Excuse me, Mohammed sir.
Right. Hello?
Sir, excuse me, sir.
Yes, sir.
Your voice is somewhat low, sir. Please just raise your voice, sir.
Now, sir, now it is okay?
Now it is, sir. Yes, sir.
Right, sir, done. And okay, right. So these are the why we are using Python means. So this is the issue. These are the some features. Libraries like NumPy, Pandas, scikit-learn, and TensorFlow. It makes easier our work, and each and everyone need to know about all these things. So next, when comes to into this introduction to signal processing, I don't want to spend more time here. So the signal processing, as you all are subject experts. It may implement analog signals and digital signals, and wherever we required. And the importance of the wireless communication, as we know well, the modulation and demodulation, error detection and correction, and channel estimation and equalization, and filtering and noise reduction. We are implementing these techniques here. And best example is now we are using in the real world mobile phone calls using signal processing to reduce noise and improve voice quality. So this is the one good example where we are implementing this AI to perform the signals, the signal processing, right? So sir already told one point in last session. So the data is in raw form. The many data is there. Many data is not a 1 kilobytes and 1 megabytes. It is very tremendous data we are generating day-to-day life regarding to sensors or image process. Videos or sensor data, video data, or voice data. But in that, we need to only some important insights we require. That's all. We don't need all data. We don't need all data to send the cloud. So this is all. This makes the traffic jam or latency increase. So that we need to filter out in ground level only. So there we need to implement all these techniques. With that, implementing AI techniques, so we can reduce the data size, so that we can send the minimal data, so that we can improve our performance. So that is very important task where we are going to implement in the performance of wireless communication. Because IoT applications are many. IoT applications are have data, and already sir told that traffic light issue is there, and also household issues are there. The many devices we need to communicate. Each and every switch you take in our home, we have one switch, means for that we need to communicate, we need to address. So in that case, so we need to make a smarter, and we need to reduce the data, and we need to send only some bits of data to cloud, bits of data, not even bytes. So each and every bit. I will show you one beautiful example. What we done in last 2 years back with that exactly suitable for this, right? Then we'll go for the traditional DPS, the transition from traditional to AI. The traditional DPS, the uses the fixed mathematical models, the rule based, but AI driven is it is used the dynamic data, adapts the automatically to change the channel variations, can make non-linear and unpredictable pattern better than DPS. And this is dynamically it learns the patterns. So The AI is like the human. We are continuously observing and getting some data, and we are giving some what we call the better results always. So that is the thing. Act as a AI act like this in this, right? So the signal. So this is the okay. Next, AI in signal processing uses the machine learning and deep learning to analyze and optimize the signals, learn patterns from data instead of relying on mathematical models, makes wireless systems adaptive and intelligent. And the traditional DBS is rule based, it having the some filters and transforms required manual tuning for each and every environment, limited in handling non-linear dynamic channels. The AI is a data-driven, learn directly from real-world signal data and automatically adapt to change the environments and can outperform DBS in complex and noisy conditions also. The role of learning approaches in wireless is in wireless communication is the role of learning approaches is there are basically we have three different types of learnings are there. AI, that is supervised learning, unsupervised learning, and reinforcement learning. These are the very simple and very common understanding terms. Supervised means as we have some labeled data and predefined data is there, and we are matching with input to output. Very simple. So we learn because you take any cell phone box and a cell phone, both are having in rectangular. If you place this is the box, this is the cell phone, we are labeled, this is the box, this is the cell phone. So like that our data having the labeled, that we called as supervised. And unsupervised is not having the labels, is not known data. It is it learns, it finds the features with data features, it make one pattern, it make one pattern. So accordingly that pattern we need to take some decisions. So reinforcement learning is also one thing where it has reward based. Continuously we are seeing the model is going towards positive manner or negative manner. Yes or no? So continuously, if it is positive, we are going on giving some rewards. So based on rewards, we can choose our application. So this is the one thing we need to know. These are the three different because I am simplifying all these things. I am giving some examples. And so these are the some supervised and unsupervised learnings, and these are the some algorithms, linear regression, logistic regression, support SVM and K nearest algorithms, and decision tree, K-mean clustering, and hierarchical clustering, and DB scan, and principal component analysis, Q learning, and SRA, and and these are the some algorithms. Commonly, I told initially we have only 10 to 20 different types of algorithms. We once we familiar with those algorithm how it works, so we can implement anywhere, right? So noise reduction, example noise, if you want to reduce the noise reduction, so the traditional filters in DPS, it use the FIR filter and IIR filter, removes noise using fixed coefficients. So these coefficients, the effective but not adaptive to sudden changes. So, but AI based noise is it reduces deep learning neural networks, learn noise characteristics, automatically separate signals from noise in real time. The example is AI-powered noise cancellation smartphone and hearing devices. So this is the one thing. And the AI is data-driven, and different ML models are there, and real-world application impact is there in with AI. And next, the core AI technologies, AI techniques in wireless signal communications are AI offers the powerful models for handling complex wireless the communication tasks. It goes beyond the traditional DPS DSP by learning patterns directly from data. The four key techniques in wireless is deep neural networks, convolutional neural networks, and reinforcement RL and auto encoders. And also we have different things are there in channel processing. What the technique we are using with this is, first is we have different, I will explain, deep neural DNN, CNN, and RNN, RL, and autoencoders, GAN and SVM, and k-mean clustering methods, and federative learnings, and graph neural networks, and Bayesian learning models, and hybrid AI DSP models are there. So these are the 12 different types of algorithms we are going to use. But in task-based, if you see task-based, that is channel processing. So one thing is channel processing. So for that we are using DNN, deep neural network, for channel equalization and prediction. And RNN, LSTM algorithm we are using for time varying channel modeling. And autoencoders, and we are using end-to-end channel coding and decoding. And Bayesian learning models are uncertainty aware channel estimation. Uncertainty and aware channel estimation. We are using these models for this one. And spectrum management. In spectrum, if you want to manage spectrum, what are the algorithms we are using? Means CNN for spectrum sensing, modulation, recognition, and GAN, generative adversarial network. For that, we are this algorithm we are using for spectrum data augmentation and channel modeling. And second thing is clustering, k-mean clustering or DB scan, the dynamic spectrum access, unsupervised. This algorithm is unsupervised. This is dynamic spectrum access. We are using this algorithm for the spectrum management. And resource allocation and optimization. We are using reinforcement learning, RL, and deep RL, and federative learning, and graph neural networks, CNN, and interfacing management in dense wireless networks. We are using GNN for interference management in dense wireless networks. And finally, we are using security and reliability. For that, we are using SVMs for jamming detection, and hybrid AI DSP models. These models we are using for combined filters, and ML for robust signal recovery. And another algorithm is there, anomaly detection for autoencoder. This the model we are using for the detect miscellaneous patterns in wireless signals. So these are some things we are using algorithms in signal processing for enhancement of performance. And next, deep neural network, DNN, channel equalization. The problem is wireless channel introduce padding and distortion and noise. The traditional method is we are using linear equalization and decision feedback equalization, and we are using, but this is the issue. And using DNN approach, we learn the channel characteristics directly from training data and collects the distortion in real time without manual modeling, and improves bit error rate and signal reliability. The applications is 5G memo systems and adaptive receivers. And the convolution neural network, particularly spectrum sensing, the problem is detecting unused spectrum, the cognitive radio in field. The traditional method is energy detection and matched filters. But we are approaching with the CNN approach is extract features from raw spectrum data, extracting features. The feature is nothing but if you take cell phone, the cell phone is have some features like length, width, color, and size, thickness, weight. So each and everything is one feature. So in our spectrum, what are the, as subject experts, we know what are the important features in the key points in our spectrum data. So those you treat as each and every one feature. So with that feature, with that data, we will make use of one model. So for that, so this is used for CNN approach. Works even in low SN, signal to noise ratio conditions. Applications are dynamic spectrum allocation in IoT and 5G. So this for dynamic spectrum allocation is also improve the performance of the wireless communication. And reinforcement learning, resources allocation. where we are using RL is resource allocation. The problem is effective use of limited wireless resources like power and spectrum. The traditional method is we are using so far rule-based allocation and optimization algorithms. All our approaches is agent, learn by interacting with the wireless environment and chosen actions like power level, frequency, bandwidth, and based on rewards. And RL, already I told the rewards, RL deals the rewards, right? This agent is also very important. The agent act as a one human. That's all. We assign some tasks, so it act as a human. Whatever we assigned some tasks, it complete the tasks. So this agent concept is also very important in AI. We need to remember. So applications are power control, channel selection, and interference management in the 5G and 6G. So autoencoders we are using in end-to-end communications. The problem is the communication pipelines has multiple hand-designed blocks, that is modulation, coding and decoding. The traditional method is each block optimized separately. For now, autoencoder approaches is treats the entire communication system as one neural network, jointly learn the encoding and decoding, and can outperform traditional modulation and coding schemes in some cases. Applications are future 6G systems we are using and efficient IoT communications. So these are the sum. So DNN robust channel equalization, CNN accurate the spectrum sensing, and RL smarter resource allocation, autoencoders, end-to-end learning of the communication systems. So together these techniques we are driving the revolution of intelligence wireless networks. The applications are application for AI in wireless communication. AI enables the intelligence, adaptive, and efficient communication systems. The key areas of applications are 5G, 6G networks, IoT networks, cognitive radio, and MIMO and massive, and wireless security issues. So the beamforming in 5G and 6G networks we are using the beamforming, that is direct signals towards the user using the AI optimized antenna arrays, increased data rates and coverage. The interference cancellation is AI models detect and suppress unwanted signals, ensures stable communication in dense urban environments. The future 6G is AI for terahertz communication, ultra low latency, and autonomous networks. Autonomous networks. AI in IoT networks are challenges. The billions of IoT, already discussed this. The billions of IoT devices need energy efficient communication. So AI solution is predict traffic patterns to reduce unnecessary transmissions and optimize sleep awake cycles for IoT sensors. So with this, we can make only single bits of communication will send from sensors to the cloud. So uses lightweight ML models for edge computing. Already sir discussed about edge computing. So we have Raspberry Pi, ESP32, and other Jetson Nano. Even ESP32 is a very cheap microcontroller, around 200-300 rupees of ESP32 microcontroller. In that also we can implement these AI models. So the fixed AI models are there, some linear models are there. So those models we can implement even in ESP32. So that is the beauty of these AI models, right? The impact is longer, not only in Raspberry Pi. So Raspberry Pi is itself is a system, and Jetson Nano is more than that, yes or no? But even in ESP32, we can implement these AI models, right? So longer device lifetime, low latency is right. The AI in cognitive radio, the problem is spectrum, the scarcity due to increasing wireless demand. So AI role is detect the unused frequency bands dynamically, spectrum sensing, allocates spectrum without interfering with licensed users, and use reinforcement learning for adaptive channel selection. The benefit is the efficient utilization for available spectrum. And AI in MIMO and massive MIMO is multiple input, multiple output. This one is multiple antennas at transmit and receiver we can use. The channel state information The prediction is complex. AI role is deep learning models predict the SCI with high accuracy and improves throughput and reduce the latency. So massive MIMO is AI-enabled real-time management of hundreds of antennas. AI for wireless security, threats, intrusion, jamming, and spoofing attacks. So that AI solution is anomaly detection using ML to spot the unused traffic patterns and reinforcement learning for adaptive anti-jamming strategies. AI-based encryption and secure authentication we can provide. So more resilient and secure the communication network we can implement. So AI is transferring wireless network at every level, 5G, 6G, and faster, smarter, interference-free communication. And IoT is energy efficiency and scalable networks. The cognitive is smart spectrum usage. So these are the some applications. Next, the practical approaches in AI for wireless communication is AI in wireless signal processing required hands-on tools and data sets. The researchers and engineers use data sets and frameworks and tools and simulators. So bridge theory with the real-world implementation. So the data sets for AI in wireless is the freely available these data sets. So once we are familiar with the data sets where we will get, so we can use those data sets. So for radio ML data sets, open data set for modulation classification contains signals under different SNR and channel conditions. So they given these data sets. And deep signal data sets are designed for AI-driven wireless tasks like spectrum sensing and modulation recognition. And synthetic wireless data sets are generated using simulators like MATLAB and Python, and useful when real-world data is limited. Limited, right? The frameworks we need to know for signals processing. TensorFlow, it is very popular for training deep learning models and supports real-time signal classification tasks. And PyCharm is flexible and widely used in research, ideal for prototyping and wireless AI models. And MATLAB is also, we are very familiar with MATLAB. Each and every faculty are familiar with MATLAB. Tools for practical implementation. So these are the open source. GNU Radio is also open source. Open source software for building radio systems. Works with DSR hardware for real world wireless testing, and DSR hardware platforms also there. There we can purchase with minimal amount, 10,000. I think 3,000 or 4,000 are there. DSRs. If you take that DSR, you attach with your system, you can start your work and you implement the AI models for your signal processing. Right. The integration of AI models trained with Python can be deployed on SDR platforms, and also GNU Radio also it works. Right. The hardware is also available and readily market. Next, the simulation is I preferred Python simulations. Of course, the MATLAB is also a very great platform. So use libraries like SciPy, NumPy, Scikit-learn, TensorFlow. You don't worry all these things. These are already readily available in what we called in IDE. So we can use just like that's all. Right. Benefits is safe, cost, right, all these things. The summary, the practical approaches, the data sets are radio ML, deep sign, and synthetic signals training AI. The frameworks are TensorFlow, PyCharm. These are the some summary of this one. Next, hardware and software components for AI in wireless is. So implementation of AI-based wireless systems required specialized hardware and software. So hardware ensures real-time signal processing, software, right? So these are USRR, Universal Software Radio, the peripherals are there, and these are the some thing, right, hardware. NVIDIA Jetson Nano is there, it acts as a Edge AI. Edge is nothing but nothing, is a microcontroller. You take any microcontroller, there we are implementing this AI means that micro, just like ES32, we say it is a Edge device. And Arduino BLE Sense is there, and Raspberry Pi, Jetson Nano, these all are, we say it is a edge devices. That's all. NVIDIA RTX is there. It is high performance where we can implement remote sensing. In those data, we can implement this RTX series. And FPGA board is also there, and 5G test beds are also available in market. With this, we can do our research in our department, used by the telecom industries and research labs. And software is MATLAB in Simulink, or we can use anything, right? And software for GNA radio. These are some hardware features. And the software for Python libraries, already I discussed all these things. So automatically available. The tool, one more thing is for this Python implementation, you go for Colab in Google, so that automatically it takes whatever libraries we required, we can implement directly there itself. I will show you one example for that. So hardware, software implementation, all these things, right? Already I discussed this. So implant real world implementation for AI in wireless is, so very 5G optimization for telecommunication, AI based stations, already discussed this one, telecommunication, right? So the research labs for AI spectrum sharing, increasing the demand for limited spectrum. AI solutions are cognitive radios plus AI detects the allocation unused frequencies, and reinforcement learning manages the spectrum access and dynamically. So the institutions like MIT, Stanford, all are using this experiment. The more efficient use of the spectrum for IoT, 5G and beyond limits, right? So we are using in telecom, base stations, smartphones, research labs, and AI readily, right? The current trends and the future directions in AI for wireless is the current trends feature wireless communication in moving towards 6G and beyond. AI is the core enabler for future networks. Key trends are AI, edge intelligence, quantum machine learnings, green wireless networks, and self-healing, and all these things. So AI in 6G and terahertz, right? Edge intelligence, already discussed this one. Sending all data to the cloud creates latency. So the solution is AI at the network edge. I will show you this example one, what we done in our company. This example right now, you see. So AI powered edge intelligence problem, sending all data to the cloud creates the latency. So the solution is AI at network edge device based, and with that we can implement these AI models. 1 minute.
Hello, sir.
Sir, is it visible, sir?
Yes, sir, visible, sir.
Right, sir. Sir, you see this small video. So what we done? This is IoT based application with the ESP32 microcontroller. So real-time IoT control and confirmation for smartphones. Confirmations. So this is one IoT application. So what we are trying to say here is, for IoT applications, whatever we have data and whatever we have networks are working very well. So it making on and off, but we don't know feedback. We don't know feedback. So for feedback, we need some solutions for that. We have some sensor based feedback is there, or image processing based feedback we have. So we implemented image based feedback system for confirmation whether the light is on or off condition, which condition it is. So we don't know. So for IoT devices, we implemented this one, but we don't know whether it is on state or off state. This there's no is a open loop. So we need closed loop. So for that we shown some solution. we don't know. Yes or no? We're sending the signal with a mobile phone, but we are not getting the output. But it is, we say it is working. But for that, we have a solution. This is. So this is the device. ASCII lens is the is name. So it is a edge device. So here we have we implemented many AI models, and it detects the object and it gives only single bit data. So if it is in on, for example, it has 7 different features are there. So with that, you take face recognition. If it recognizes the face, the entire AI models perform within the device, and at the end of the day, at the end, it gives only 1, 0 or 1. If face detected, it sends the 1, otherwise 0. That's all. So that is the minimal data. But the same face detection, if you want to perform with our system, means we need to transmit entire video, yes or no, entire image. But here we done everything at a device level, and we are sending only 0 or 1. That's all. We are picking 0 or 1. That 0 or 1 single bit we are sending to cloud. So with that we can take this as a AI model for implementing in AI IoT applications using. Right. Light on. I think you got it. Right. Send as a light on, received light is off. See, we within seconds we are transmitting the single bit to cloud. So this is the we are implementing AI models in edge level itself. Right. Thank you. And I will show an example of collab examples. Right. So the collab is the one online platform for implementation of all these things. Mahbub sir, it is visible?
Yes, sir, visible, sir.
Right, sir, right, sir. So this is the one program we taken from ChatGPT, and we are implementing this for signal filtering. I will show you. Right. You just give some input for ChatGPT. It generates all these things, and we implementing in Colabs. You just run it. It runs, and it gives the output. It gives the output. So we generated original versus noisy signal, and the traditional DBS and FIR signals, right? The AI-based noise reduction, MLP. So it gives like this. Dynamically, it gives the data. Yes or no? So this is the very simple logic, very simple program. So that's why I say, I used to say always, so as we are expert in subject, so we need only problem statement. So if we are aware of problem statement and just give to any the generative models, it generates the program, and only we need to know about the process, what the algorithms, how algorithms will work, and how to implement that in real time. So like this we can implement, right? Mahmood sir, it is visible clearly?
Sir, visible, sir. Visible, sir.
Right. Thank you, sir. So this is another program for BPSK constellation and QPS constellation. So here, this is also given in ChatGPT. It generated. It gives. We can implement. We can implement in Google itself. No need to install any Python, PyCharm, anything. So the beauty of this collab is it implements itself libraries. So here NumPy we used. You see what are the libraries we used in this NumPy, Matplotlib, scikit-learn models, and right. These are the things, right? Right. So like this we can implement many applications. It generates like this. Okay. So the decision boundary of DSK and DSP. So this is the ultimately I want to show you. And okay, right. And one more thing I would like to submit for this is right. Machine learning concepts. I will explain something here. Yeah. So these are the some small library. I mean, the libraries we required to know about these ML concepts where we need to implement. So NumPy, Pandas, scikit-learn, and these are the scikit-learn libraries. And see the data we are splitting into X and Y data targets, and we are training the test split X train and X test, Y train and Y test. So we are using 3 or 4 different types of lines, and these are the some models in Python from see this model logistic regression model we are implementing for one application. So 3 or 4 lines of code, the evaluation, we can print accuracy score and classification reports for this. So with this, we can see the 3 or 4 line code we want to implement. That's all. So the random forest, k-near neighbor models, so SVMs. And the performance comparison, we have all these models, right? And for classification, so we have all these things. Simple. So linear regression and decision tree regression, random forest, and k-nearest. So these are the very simple 3 or 4 lines of program is there for in Python. So we can implement our whatever we required in our subject, right? So these are the boosting and bagging algorithms are there for performance testing. We can use very simple coding already shown in Google Colab, right? Right. So for the practical implementation, you go for Colab or PyCharm, or you take any VS Code, we can implement. So as time constraint, I stop here. I think that I thought that I share some real world applications and also we have a great time. And I thanks to our Imran San who gave this opportunity to present, and thanks to the management of St. Joseph Engineering College. Emeganur, the principal sir and HOD madam, and all. I thanks once again for giving this opportunity, and I thank all participants who spend more time, almost 1 hour 15 minutes with us, and we shared what we know about this AI models in signal processing, and I hope we'll find some other time we'll meet again, and from our company side, we are working with all these technologies, and also we are selling IoT trainer kits, AIML trainer kits, and robotics wherever you required. So please contact with us, our company, Asina Technologies, as we have started a startup company in 2021, and we are growing up, and sure, no doubt, we'll be in better position in next couple of years. And this is the great opportunity for all faculty or any other individual students as well as faculty. So we need to start these startups because we have a great knowledge and we have a what we call surplus. Not only great knowledge, we have surplus knowledge. So with that, we can do wonders in industry. So that I
Bola sir.
request, appeal all faculty members, please think of towards the startups, and you take initiate to start startups. Nothing will go. So with minimum budget, we can start and find one great or one fixed problem. For that, you address one solution. So that is enough for making money. So at the end of the day, we need to make money with our knowledge. So that I appeal and I request all faculty members think of towards the to start startups in our India, and the great opportunity is there in our India because world market we have 140 crores of people are there. We need to serve for them in better way so that we have a great opportunity. So as we have surplus knowledge, we can utilize in proper way in startup format. So we'll get great reward towards ourselves in form of money, in form of what we called respect or whatever it is, so we can get better career in startups. Is my personal opinion and a personal request. I appeal all faculty members think of about the startups. The companies only make money much more. So that is the ultimately. So that you think of in this regard. And I thank all participants who gave this opportunity, patiently listen what I say. Thank you very much. Thank you, sir, for all of you. I close my session here, and I will join again when we find time. Thank you, sir. Imran sir, I thank Imran sir and Mahbub Basha sir and Nassima Reddy sir, because St. Joseph College means I know Nassima Reddy sir very well.
Thank you, sir. Thank you very much, sir. Dear
I-
participants, sir.
Yeah,
Dear participants, if you are having any queries, means
please.
you can clarify with our resource person, sir.
Sure, definitely. And also, my card is there at the end of this. This is my card, so that you contact in my personal number, WhatsApp, or you mail to this. We'll respond for our products, for our any startup starting recording. We'll help in this regard. How to start startups? It's around 50,000, 1 lakh. So 30-40,000, we can start the one startup. That's all. Registration process is done. Then we'll put some money for prototyping. We can approach for VPs, venture capitalist, and we'll get some money. No issue. The government of India is also promoting for startups. So we have great opportunity in this. Right. Thank you. Sir, okay. Mahbub Basha, sir, can I?
Sir,
I
you
think
are
I
yes,
completed
sir.
the time.
Yes, sir. Your depth of knowledge and ability to explain with clarity has enrich a great value to our FDP, sir. Once again, thank you for your sharing your expertise with us, sir. Thank you, sir.
Thank you very much, sir. I will read this. Right.
Dear
Thank you, sir.
participants,
Sir,
if
thank
you
you.
have
Thank
any
you, sir.
doubts, you can clarify with our resource person.
Yes, sir. Any doubt, please?
Sir,
Yes,
thank
sir,
you.
I have.
Dr. Nasim Hardy, sir.
Sir, one student is asking, sir,
Nasim
one
Reddy, sir, is
participant.
there? Sir, Nasim
Yes, sir.
Reddy,
Yes, sir. Yes, sir. Thank you. I am listening your valuable session, sir. Good insights and
Nothing, sir.
AI plus wireless communication.
Nothing, sir. Okay, thank you, sir. Thank you.
Thank you, sir.
Right.
Sir, good evening, sir.
Yes, madam.
Sir,
Good evening.
one doubt, sir.
Sir, the session was very nice. I'm a PG student from SJSET. So can you please share the PPTs and also contact details? I couldn't able to see your screen actually when you are sharing your contact card.
Yeah, right now also I shared my contact card.
No, sir. I can see your Google Colab screen.
Okay. Sorry.
I-
One minute. One minute.
Please.
Right.
Where
Right.
is meeting?
Right. You go through this one. You take snap. 970309327 is my personal number. You contact in that, no issue. Really, we help in how to start the startups, the process, whatever. Because we started in 2021. Now we are exporting to our products to foreign countries. Recently, in last year, we exported to Morocco our IoT trainer kits and AML trainer kits. AIML trainer kits, we only manufacturing in India. You just Google it. The manufacturer AI trainer kit manufacturer in India. Our company will come first without any what we call promotion. We got that position. So that because the lack of awareness in regard AI ML technology implement in college level, we are lagging in AI ML trainer kits because the implementation AML concepts in only we are performing in data based, only data, numerical data based only. So that is that too the predefined data sets we have, that in that we are implementing. But AML concepts we need to implement in image processing, voice processing, and many more applications where we are meeting real world applications in security, home applications, anywhere there that we can perform with our trainer kit. So OpenCV, OpenMV are there, two tools. OpenCV, note down. OpenCV and OpenMV is there. For that, great hardware tools are available. So with that, we can perform many applications. So whatever we feel difficult, we can implement. So from our side, we'll clarify. At the end of the day, we need to make product. We need to make give the address to one problem. That's all. So we need to give address. That's all. Definitely, we need to address the problem. That's all. Yes or no? Because as we are aware of all subject, without making one product, one solution, is a difficult task for us only, right? So we'll help. Really, we help in regarding to how to start the startups and what are the procedures, GST registration, even ICE gate registration, everything. Yes, yes, madam. We will clarify. No issue. Right. Any other doubts?
So thank you
Thank you, sir. Madam.
for your
Sir,
valuable
thank you very much, sir.
session.
Thank you very much, sir. Mohammed, sir.
Sir, yes, Mahbub sir.
Thank you very much, sir, for your
Thank you, sir.
valuable
I'm
session.
leaving, sir, my session.
Okay, sir.
Sir, if possible, can you please share your PPT?
Okay, madam. We'll share you
Yeah,
everything
I will share
after
to
completion of this
transfer
FDP, madam.
that.
Sure. Sure, sir. Thank you.
Okay,
Thank you.
madam. Dear participants, feedback form has been kept in the chat box. You please kindly fill the feedback form as early as possible. All the participants are requested to fill the feedback form as early as possible. बोलो सर. पता सर दाన్ని 2 बार रखी हूँ, अब 1 बार रखता हूँ.
Hello, sir. Hello, sir.
Hello.
Sir, actually at 7:30, due to technical issue, I logged out from the session, sir. Again, I joined, but feedback link missed for session 5, sir.
Okay sir, Google will take care of everything. Sir, attendance will take Google this Zoom.
Okay, sir. Mandatory for that one. That's why I'm asking actually
Okay sir, fine sir.
regarding the feedback link.
Okay sir.
Hello. Hello, Imran sir.
Participants, now both the sessions feedback link is available in the chat box. Whoever missed for session 5, please avail this opportunity. Meeting will be ended in 2 to 3 minutes. Participants are requested to fill the form fast.
Dear participants, session 5 and session 6 feedback form is available. Please, those who have not filled, you please try to complete now itself.
Sir, how many sessions are mandatory to get the certificate?
At least you must get above 80%, madam, attendance.
Above 80%.
And you are going to have a assessment also. You are going to have a test also.
Yes, sir. Yes.
Okay, madam.
So, I couldn't able to attend the first day class, so I just asked.
For remaining sessions, you try to attend, madam.
Sir, sir. Sure, sir.
Okay, fine, madam.
Thank you, sir. Good night.
Okay, madam.
Mahbub sir, I am ending the session.